This video is for Chapter 4, Section 4.1 for the math activity Divisibility with base 10 pieces. We'll use base 5 and base 10 pieces, and we'll look at divisibility tests for 3, 4, and 9. In question 1, we look at this base 5 numeral 1, 4, 3 and the corresponding base 5 pieces. If you think about the base 5 pieces, and you break them up, if you take off 1 unit from each of these flats and longs, you can see what remains are in groups of 4. I have that modeled here, 1, 4, 3 base 5. If I split it up, I've split up these longs. These are groups of 4, so there's those extra units pulled down. These units here make those a long. And then when I split up these longs and I pull out these extra units, I have this 1 unit left over. And so there's a group of 4. These are all groups of 4. So these pieces here can all be put into 4 groups evenly. And then the question about whether my original 1, 4, 3 was divisible by 4 in base 5 just boils down to whether these units here, 1 from the flat, 1 from each of the longs, and 3, the original units, when that is added up, if that's divisible by 4. So it's for you to explain that in part A, and then in part B, try that with another number. Notice that 4 is 1 less than our base 5. Now in question 2, we move to base 10. And we're going to do a similar thing with divisibility by 3 and divisibility by 9. So we have a number here, 342, and the question is it divisible by 9? If you think about taking this flat and pulling off a single unit, you're left with 99 units. Is 99 divisible by 9? When you look at these longs, if you pull off 1 unit, you're left with 9 units. Are 9 units divisible by 9? And so you can see you have a similar situation here. 1 unit from each flat, the little corner unit, 1 unit from each long, and the original units. If you add those together, are they divisible by 9? You'll notice the question also asked about divisibility by 3. If you think about a long in base 10, if I break that up, that's 10 pieces. So there's my unit counter, the one I pull off, and then I'm left with 9. But of course 9 can always be made into 3 groups of 3. So in question 2, you'll want to explain how each flat and long can be divided into groups of 3 or 9 with 1 unit remaining on each of them. This will help you understand the divisibility test for 3 and 9. And when you figure that out, you'll want to state a rule, and then we ask you a couple of questions. If a number is divisible by 3, does it make it divisible by 9? And what about the other direction? And then finally in question 3, we're going to look about divisibility by 4 in base 10. So again, we have the same picture, 3, 4, 2. When you look at a flat in base 10, that's 100 units. Is a flat divisible by 4? You can think about drawing a line this way and drawing a line this way and turning it into quarters. Will that be even units? So once you think about the flats, you can think about all higher place values, which are really just flats combined, and perhaps they won't matter to your calculation. Now we don't get the same pulling off one unit idea with the longs and the units. We might have to consider those individually. So that should get you going with question 3, and I hope you have fun with Math Activity 4.1 and learning about divisibility and how to support that with base piece models.